All right, today we're going to start looking at confidence intervals. And the basic idea of confidence intervals is going to be how would we predict or find the true population parameter from a sample. One of the examples that I like to use is looking at disposable batteries like Duracell Everready batteries. Well, they claim that the batteries last 8 hours. How do they know that they last 8 hours? The only way to test the life of one of these batteries is to actually drain it. And it's not a rechargeable battery. So, therefore, you wouldn't be able to reuse the battery that you drained to test to find out the average length of its life. So, how are they confident that that's the true life of all their batteries? Because if they were to test every single battery made, they wouldn't have any batteries to sell. So, what we're going to do is we're going to use a sample statistic to estimate a population parameter. So, from a very small sample of data, we'll be able to find the true answer for the entire population within a certain range. We will be certain confident as to what the true value of the population parameter is by using the statistic from the sample as an estimator of the population's parameter. So we're going to try to figure out what's the true answer of the entire population from a small sample. That's the whole idea of confidence intervals and estimating with confidence. So every single confidence interval in the world will have the same basic format. Every confidence interval in the world will have a format where we'll take an estimate plus or minus a margin of error. Now, what we use as the estimate and how we calculate the margin of error will change depending on the problem. So, the book will talk about point estimator and the point estimate. That would be this right here, the estimate. Remember, in the previous chapters, we talked about X bar is a estimator of mu. P hat is a estimator of P. We would say that X bar is an unbiased estimator if X bar is truly close to the population parameter mu. Same with P hat and P. So the point estimate, it's either going to be X bar or it's going to be P hat. Because again, what are we trying to do? We're trying to use the sample statistic X bar P hat to estimate the population parameter mu or P. So the point estimate is going to be the statistic that we calculate from our sample of data. So a point estimator is a statistic that provides an estimate for the entire population. So point estimators, X bar, P hat. What do they estimate? Mu, P. Okay. Every single confidence interval in the world is going to have this exact same form, estimate plus or minus margin of error. We'll get into the nuts and bolts of how to calculate these as we move through this unit. Okay, let's look at an example here real quick. Okay, identify the point estimator you use to estimate the parameter in each of the following settings and calculate the value of the point estimate. So the example that I was referring to a minute ago about the lifetime of batteries. So you can see here we have a quality control inspector wants to estimate the mean lifetime mu of all AA batteries produced by this factory. So they want to estimate the every single battery ever produced by this factory. Well, we can't. We cannot test every single battery. It's just not feasible. We don't have enough time. Plus, we would lose all of our product. So what they did is they took a SRS or a random sample of 50 batteries and they drain those batteries under normal use. Then from there, they're going to determine what is the true value for the entire population based off of the sample of these 50 batteries. So right now we're just looking at the point estimate or what's the center of our interval going to be. So what would be the point estimate? So what we would do is we would take these 50 data points that we have here, these 50 batteries that we drained, and we come to our favorite tool, the calculator. We go stat, edit, right? I'm going to clear out these lists. Remember, go up to the top and highlight it, hit clear and then arrow down, and it will get rid of everything in the list for us. So let's clean these up here. We could do that for each one. All right. Now, here I would type in all 50 points. That's a lot. I'd put in 16.73, enter. And then I would put in the next one, 15.6, and I would do that for all 50 points, and then I would do one variable, stats. Now, if I were to spend the time to do that right now, I would have all 50 data points in there, and then I would just hit one bar stats to get the answers. So I already did that, but I'm not going to waste your time watching me type in 50 numbers. So after I did that, I put in, 16.73 plus 15.6 plus, until I've done that all the way to the last one, 17.55. Okay? And then divide that by the total number 50, and that would give me X bar, my sample statistic, which in this case would be my point estimate. Okay? The value of that statistic, X bar, would be my point estimate. So I would say 16.718. That would be the sample mean life of these 50 batteries that were randomly selected from the factory. Now, this 16.78 is not going to be the true answer for the entire population of every battery. It's going to be my starting point in which I'm going to use to estimate mu, the true mean life of every battery produced. So my point estimate in this case would be 16.718. So that's how I would find the estimate for part A. And again, the estimate would go up in the front, estimate plus or minus margin of error. If I look at question B, it wants to know what proportion of the US adults would classify themselves as vegan or vegetarian. Well, there's no way I can ask every single person in the United States. I can't be done. So I'm going to take a SRS of people in the United States and use that to estimate the true proportion for the entire country. So the first one was quantitative data. How long does your battery last? It was a numerical value. Quantitative, we use X bar. X bar is the unbiased estimator of mu. Well, part B says, what proportion are vegetarians? So are you a vegetarian? You can't answer that with 3, 7. It doesn't make sense. It's not quantitative, it's categorical. Therefore, the point estimate cannot be quantitative, such as X bar. It's going to be P hat. So what would be the point estimate for question B? Well, remember, P hat is the sample proportion. So 124 people answered, yes, I'm a vegetarian, out of the 1,473 in our SRS. So after we sampled 1,473 randomly selected adults in the United States, 124 of them said, yep, I'm a vegetarian. So our point estimate for this, our estimate for our margin of error, would simply be the proportion 124 divided by 1473, which is approximately 0.084. So that's how we would find our estimator for this confidence interval. And finally, part C says, the quality control inspectors in part A, so again referring to the battery problem, estimates the population standard deviation sigma. So remember, X bar estimates mu. P hat estimates P. They want an estimator of sigma. What was it that estimates sigma? That's S. So we just type it into the calculator once again, and we hit one bar stats, and it comes up with a sample standard deviation S to be 0.664. So this 0.664 is the unbiased estimator of sigma. S is the sample standard deviation, and it estimates the population's standard deviation. So that's how we would find the estimate or point estimator. All right, what is a confidence interval? Okay, a confidence interval is going to have two parts. It's going to be made up of an interval as well as a level. So what we're going to be able to do is say, I'm 99% true. I'm 99% confident that the true population parameter falls between this and this. So it gives us plausible values for the parameter based on the sample. So again, how can I be certain what's the true answer for every battery in the world when I didn't test every battery? Well, I can't tell you the exact answer, but I can tell you I'm so certainly confident at a certain level that the true answer falls between these two values. So when we make a confidence interval, you're going to want to follow this sentence frame right here. So to interpret a confidence interval, we're going to say the same sentence every single time. Over and over and over and over again, we're going to repeat the same sentence. So 95% is the most commonly used level for a confidence interval. But certainly we could have a 99% or a 96% or a 99.9%. Any of those values we could have, but 95 will be the most commonly used confidence interval. 95% should sound familiar to you in this course because it fits the 68, 95, 99.7 rule. 95% is roughly 2 standard deviations on either side of the mean. Okay, so we are 95% confident that, let's say, let's look at the battery. If I were to create a 95% confidence interval for the mean lifetime of the batteries produced by this factory, I would say I am 95% confident that the true mean life of all batteries produced by this company is in the interval Remember, our point estimator was 16.7. We found for that battery problem that X bar equaled approximately 16.7 hours with a standard deviation of approximately 0.66 hours. So we would say I am 95% confident the true mean life of all batteries produced by this company is somewhere between 15.5 and 18.2 hours. So this sentence frame is going to be super important for us. We are 95% confident that the interval from 15.5 hours to 18.2 hours captures the true population parameter. So when you see up here, parameter in context, we're going to be yelling and screaming at you the rest of the year that all of your answers need to be in context. No more the answer is 12. The answer is between 15 and 18. The answer to what? Okay. X doesn't mean anything in statistics unless we give it context. So please get comfortable and familiar with writing your answer in context of the problem, which I tried to model underneath for you here. Okay. So every interval, a confidence interval, has two parts. It has a confidence level and an interval. The level is how confident are we that we captured the true population parameter.